Welcome to the AI Coach by Anil Nathu.
It's really great to be here today.
Yeah, we are thrilled to have you. So picture this scenario, right? Because I guarantee almost everyone listening right now has been here.
Oh, absolutely.
You sit down at your computer, you have this brilliant idea, and you type this incredibly complex prompt into Claude.
You hit enter and then you just wait.
Right. You hit enter, the little wheel spins, and you wait some more. And then finally, you get this watered-down, super generic response.
Accompanied by that quiet little notification that your API credits are just vanishing.
Exactly. Vanishing into thin air. If you are sitting there right now using Obsidian as your personal knowledge base and you have Claude hooked up as your AI assistant, I really need you to brace yourself today.
Yeah, because you are almost certainly burning money.
Burning money, and you are definitely, without a doubt, sacrificing speed.
It's a really harsh truth, I know.
Yeah.
But it's a very necessary one to confront. Because we see this dynamic, well, constantly.
People spend months, right, sometimes years, just building these beautiful, sprawling digital gardens.
Oh, the meticulously interlinked vaults, yes. They document everything. And then they plug a large language model into it, expecting pure magic.
But instead of magic, they get sluggish responses.
Sluggish responses, frequent hallucinations, and just sky-high API bills. They assume the AI is just, acting up.
But the reality is entirely different, isn't it?
Yeah, the reality is that the environment itself is the trap.
An unoptimized vault with just, say, 1,000 files.
Which, let's be honest, is actually quite small for a dedicated Obsidian user.
Right, 1,000 files is nothing. But that small vault can waste anywhere from 50,000 to 150,000 tokens on overhead alone.
Per session. That's the crazy part. Per session.
That is just the baseline tax you pay before Claude even does anything useful, before it writes a single word.
Exactly. Before it summarizes a single thought, it's just burning through tokens trying to read your messy filing system.
Okay, let's unpack this, because our mission today is to completely demolish that maze.
We are going to unpack a really comprehensive framework today. A 33-rule guide.
33 rules that promise to cut your token costs by up to 80%.
Which is massive. We're talking about speeding up your AI's responses dramatically.
And more importantly, freeing up its context window for actual, meaningful, complex work.
Yes. So where do we even start with a problem this deeply embedded?
Well, we have to start by understanding the invisible mechanics, right?
Right. Before we can start rearranging folders and renaming files, you really have to understand what a token actually is.
Mechanically speaking.
Exactly. And why it carries a very real price tag.
Because we hear the word token thrown around all the time, But I think a lot of people just assume a token is exactly equal to one word.
It's such a common misconception. In the world of large language models, a token is just the fundamental unit of data that the model's tokenizer breaks text into.
So it's not a one-to-one ratio with words?
Not at all. Roughly speaking, for standard English, one token equals about 3/4 of a word. But the way the tokenizer chunks text is based on probability.
Probability and frequency in its training data, right?
Yes, exactly. So a really common word, like apple, might be just one token.
Okay, that makes sense.
But a highly specific, hyphenated, multisyllabic technical term, that might get chopped into 3 or 4 tokens.
So a full descriptive sentence might be around 20 tokens?
Right. And a really long, heavily punctuated file name could easily be 15 tokens, all on its own.
It seems like pennies in isolation, honestly. Who cares about 15 tokens?
That does seem small. But here's the critical mechanical reality you have to grasp. Claude reads a vault top-down.
Top-down. Okay, what does that mean in practice?
When you give it access to your Obsidian directory, it does not possess human intuition. It doesn't just magically teleport to the one specific file you want.
It has to span the whole thing.
It often has to ingest file names, folder paths, and front matter across the entire system just to map out the context.
So every single letter, every forward slash in a nested folder path.
Every redundant word in a file name. It all gets converted into these tokens, and you pay for every single one of them.
I like to think of it this way, actually. Imagine you hire a brilliant, world-class researcher.
Okay, I like this analogy.
You're paying them by the hour, and they are not cheap. But instead of just handing them the specific book you want them to summarize, you force them to stand in the lobby.
Oh, and read the entire library catalog system
Yes,
aloud.
aloud, including all the Dewey Decimal numbers, the publication dates, the author bios, every single time you ask them a question.
That sounds exhausting.
Right. You ask, what is the capital of France? And they have to read the index of the encyclopedia before they are allowed to answer Paris.
That is exactly what you're doing to Claude when your vault isn't optimized. It's a phenomenal analogy.
And it highlights precisely why this framework is so vital.
It's not just about the financial cost either.
Mm-hmm.
Though, if you use the API heavily for daily tasks, those fractions of a cent compound
They compound into hundreds of dollars incredibly fast.
very fast.
Oh.
It's also about speed, because reading that massive digital catalog takes processing time.
But crucially, it's about the context window limit, isn't it?
Yes, the AI's working memory. Claude has a fixed memory capacity per session. Let's say it can hold 100,000 tokens in its active brain.
Okay.
If you fill 80,000 of those tokens with sprawling folder names, repetitive tags, and unnecessary metadata.
You leave only 20,000 tokens for the actual work.
Exactly. You leave almost nothing for the model to hold the actual logic, nuance, and instructions required to solve your complex problem.
The model gets dumbed down simply because its working memory is full of garbage.
That's perfectly stated.
As outlined in this incredibly detailed guide from the AI Coach by Anil Nathu, fixing the structure makes the savings automatic.
That's the beauty of it. Once you rebuild the architecture, you reap the benefits on every single prompt, forever.
It becomes passive optimization. So let's dive into the very first physical layer of this architecture, how we name our files.
File naming. The Wild West.
Because I know I am personally guilty of treating file names like mini summaries.
We all are, honestly.
I'll write something like Artificial Intelligence Tools and Platforms Overview 2026.md.
Of course you do, because you want to know exactly what is in the file just by glancing at the title.
Right. I have a human navigating a visual interface. I need visual categorization.
Humans have a deep-seated psychological need for that.
Yeah.
We use the file name to comfort ourselves.
But for Claude, that is terrible, right?
The file name's job is simply to identify the note. The content inside the note is what explains it.
So reading that massive string of words I just described is a total waste.
An absolute waste of tokens.
Yeah.
To a machine, the identifier should just be a tools. That's rule 1. Keep names short, like 4 to 5 words max.
But wait, if I just name it iTools, how does Claude, or more importantly, how do I know what kind of file it is when I'm looking at a list of hundreds of notes?
This brings us to rule 2. You have to adopt a machine-first mindset. You use short 3 to 4 character prefixes.
Okay, like what?
If you use prefixes like MOC for map of content, PRJ for project, REF for reference, or ARC for archive,
Oh, I see.
you give Claude instant, low-token categorization without it ever having to open the file.
Let's pause right there, actually, because map of content, or MOC, is a term that gets thrown around a lot in productivity circles.
It does, yeah, it's a buzzword.
Let's define it for anyone new to this deep dive. What exactly is a map of content in a 30-second breakdown?
Think of a map of content like the switchboard operator for a specific topic in your brain.
Switchboard operator, okay.
Instead of having 50 random notes about artificial intelligence scattered everywhere, an MOC is one single hub note.
It summarizes and links out to all your other notes.
Exactly. It acts as your personalized Wikipedia landing page for that subject. We will dive deep into why MOCs are the ultimate secret weapon later.
But for now, just know that prefixing a file with MOC- tells Claude, hey, this is a high-level summary.
Yes, and a file named PRJ-website rebrand tells the AI immediately that this is an active project.
It saves Claude from accidentally loading hundreds of archival reference files.
Right, like when you just ask it to give you a status update on your active work, it's incredibly clean.
Now, moving past prefixes, there is a very specific rule 3 about the characters we use in these names.
The hyphen rule.
The framework insists on hyphens only, no underscores, and absolutely no spaces.
Yes, spaces break file paths and cause terminal errors, so those are out.
I understand the spaces, but what is the vendetta against underscores?
The underscore issue is a fascinating peek into how large language models actually process language at the byte level.
Really? How so?
Underscores add friction to the tokenization process. Remember how we said the tokenizer chunks text based on its training data?
Right, standard internet text and literature.
Well, in those massive data sets, spaces and hyphens are the natural bridges between words. Hyphens tokenize very cleanly.
But underscores are mostly used in programming code, right? Like snake case variables.
Exactly. Because they are less common in natural language, underscores can sometimes be read by the tokenizer as entirely separate characters.
Oh, wow.
Or they can trigger different, less efficient token boundaries. So A tools with a hyphen might be 2 tokens.
But with an underscore.
With an underscore, A tools might be processed as 3 or 4 tokens depending on the model's architecture.
Creating unnecessary bloat. So hyphens keep the token count cheap and the processing clean.
Exactly. But Rule 4 has a fascinating exception to the no underscore rule.
Right. The framework suggests using a leading underscore for your absolute priority files, like your main index file.
So you name it, underscore index.fmd.
Why break the rule here?
Because in this specific context, you are hacking the alphabetical sorting system.
Hacking it how?
A leading underscore acts as an alphabetical forcing function. In almost every operating system and directory tree, symbols sort before letters.
It physically forces that file to the very top of any directory listing.
And because Claude reads top-down, you want your most critical instruction files, your master index, read first.
Before Claude consumes its limited token budget on lower priority content, you are controlling the sequence of ingestion.
You are physically organizing the digital shelf so that the most important book is the very first one the researcher bumps into.
I love that. Now, Rule 5 is one I know is going to hurt some feelings in the Obsidian community.
Oh, keeping dates out of file names, I know.
Chronological sorting by file name is deeply ingrained in many popular note-taking methodologies. People love seeing 2026-03-22 meeting.md.
But again, think about the token math.
Right.
If you put that 10-character date string at the start of 50 different files, Claude has to read those numbers every single time it scans the folder.
Even if you're just asking for a conceptual summary where the date is completely irrelevant.
Yes. Now, if the note is literally just a chronological, like a daily journal, then naming it by the date is fine.
But for a reference note, put the date inside the file's metadata, the front matter.
It costs absolutely 0 tokens to load when the file is closed, and the system is just scanning directory paths.
But it's there if Claude actually needs to open the file and read the chronological context.
Precisely, which brings us perfectly to the next layer of the vault, the folder structure itself, Rules 6 through 11.
Because if file names are the books, folders are the shelves and the aisles.
A sprawling structure means Claude gets lost. A tight structure means it finds the context immediately.
Rule 6 is the overarching one here. Maximum 2 folder levels deep.
We have to completely abandon this nesting doll madness that so many of us fall into.
Oh, I am so guilty of this.
I think we all are at some point.
I will have a work folder, leading to a clients folder, leading to an active folder,
Leading to an Acme Core folder, leading to a Project Alpha folder.
leading to a meeting notes folder, just to hold one tiny brief.
And that feels highly organized to a human. But let's look at the mechanical cost. Every folder name in that path becomes part of the file's absolute path.
Right, /work, /client, /active.
The AI pays the token cost of all those nested folder names on every single read of that file.
And every time it stands at the directory tree to find it.
It's compounding interest, but working actively against you. Keep it to 2 levels. Keep it flat.
To manage a flat structure, Rule 7 suggests numbering your folders for predictable ordering.
Things like 000 mock, 100 admin, 200 projects.
This ties right back to the top-down reading mechanism, doesn't it? Removing the randomness of the alphabet.
It does. You are explicitly telling Claude the hierarchy of your universe.
Which is why your maps of content folder, Rule 8, must be numbered 000. It guarantees it is the very first thing Claude sees.
Right. Rule 9 says keep the folder names short and lowercase. But Rule 10 is the guideline that I think is the biggest paradigm shift for most users.
Let's hear it.
The framework states we should organize our folders by note type, not by topic.
I need to push back here, honestly, because my instinct is completely the opposite.
I hear that a lot.
I have a folder for marketing, a folder for AI tools, a folder for recipes. It feels natural to group subjects together.
Of course it does.
Putting a home renovation project in the same 200 projects folder as a podcast launch project feels like creating a totally different kind of mess.
I completely understand that reaction. But if we connect this to the bigger picture of how machines parse information, we have to remember that Claude does not think like a human.
Right.
We love topical folders because they give us visual comfort. But Claude gets bogged down by them because topical folders fragment knowledge across a rigid physical structure.
How so? Give me an example.
Let's take your example. You have a note about a new AI tool that helps with podcast marketing.
Okay.
Does that note go to the AI tools folder, the marketing folder, or the podcast folder?
Probably marketing. Or maybe I create a subfolder. Oh, wait, no, I can't do that anymore because of the two-level rule.
Exactly. The physical location becomes a bottleneck. If you put it in marketing, and you later ask Claude to review your entire AI tools landscape,
Claude might miss that crucial note entirely.
unless it burns tens of thousands of tokens, scanning the whole vault to find stragglers. Instead, this framework aligns beautifully with systems like the PRA method.
PARA. Okay, let's break PRA down really quickly for the listener.
In short, PRA organizes information by its actionability, its state of being, rather than its subject matter.
Projects, areas, resources, and archives.
Right. Projects are active things you are working on. Areas are ongoing responsibilities. Resources are reference materials. Archives are inactive things.
So my podcast launch and my home renovation both go in the projects folder.
Because their type is the same. They are active tasks requiring execution.
But then how does Claude know what the topic is? How does it connect the podcast project to the podcast marketing resource?
That is exactly what the maps of content are for.
Hmm.
You use an MOC file to link topics together conceptually.
Oh, rather than relying on the folder structure to do it physically.
Yes, folders separate the kind of data. Files define the meaning of the data.
Okay, that is a massive conceptual shift, but it makes perfect sense. The physical structure is just for the machine's efficiency.
And the conceptual links inside the notes handle the human meaning.
Which brings us to the final structural rule, Rule 11. Archive, do not delete. Move inactive notes to a 500 archive folder and explicitly tell Claude to ignore it.
Never delete knowledge that might have future value. Just isolate it.
By explicitly exiling the archive folder in your system prompts, you preserve your history without forcing Claude to read through your old, abandoned drafts from 4 years ago.
Exactly. Every time it tries to help you solve a problem today.
So we've rebuilt the shelves, we've flattened the folders, we've renamed the files, we've hidden the archives.
The maze is gone.
But what about the books themselves? Because if the folders are the maze, the actual paragraphs inside your notes are the quicksand for an AI.
This is section 2 of the guide, rules 12 through 19. Moving from where things live to what is actually inside them.
Because every single word inside a note has a token price tag.
This is where we see the highest impact on a daily basis. A well-written note delivers high value at a minimal token cost.
A poorly written note forces Claude to pan for gold in a river of mud.
Beautifully put. Rule 12 is the golden rule here. The most important writing habit you can develop for AI.
What is it?
Lead with a dense summary. Put the most important information, the absolute core insight, in the first 3 to 5 lines of the note.
This is like the classic inverted pyramid in journalism. Don't bury the lead.
Because Claude reads top down, right?
Yes. If your main insight is buried at the bottom of a 2,000-word rambling thought process, Claude has to consume the entire file's worth of tokens before it finds the answer.
If the note is about a specific software tool, the very first line should be, tool name, best for beginners, weakness, hallucinates local data, best use case, .menu copy. Boom.
20 tokens, maximum value extracted instantly.
Do not start with, in this note, I want to share some thoughts I have developed over time.
I feel personally attacked by that example, but it is so true. We write for ourselves, we warm up to our points, and we use filler.
And that filler extends to the metadata, too. Rule 13 stresses keeping your front matter incredibly lean, 3 to 4 fields maximum.
People hoard metadata. Obsidian allows you to add YAML front matter to the top of every note, and users go crazy with it.
They add aliases, mood trackers, daily word counts, review statuses, source URLs, author names, all into the front matter.
But the front matter is loaded and read on every single file scan.
If Claude cannot actively use that metadata to complete a specific logical task, it is pure overhead. Stick to title, type, tags, and maybe the date it was last updated.
Everything else is just a vanity metric that you are paying an AI to read.
And when you get into the body of the note, Rule 14 is to write in compressed prose with 0 padding.
I noticed this when I started optimizing my own vault. I would ask Claude to extract facts from a messy paragraph, and it would sometimes hallucinate or get confused.
But when you stripped out the conversational filler,
it was razor sharp. If I stop writing, based on my research and personal experience, I have come to the conclusion that Make.com is preferred over Zapier.
And you just state the conclusion, Make.com is preferred over Zapier.
I just saved 15 tokens, and the factual extraction is identical.
Every single word must earn its keep. And this highlights Rule 15, a very common duplication of effort, restating the title inside the note body.
Right. The file name is already tokenized. The front matter title is tokenized.
The main H1 header at the top of the document is tokenized.
If your first sentence is, "This note covers everything I know about X," you are paying double, sometimes triple, for absolutely zero new information.
Just dives straight into the dense summary.
Rule 16 deals with how these notes connect to each other. We need to limit our wiki links to only what Claude absolutely needs to complete a task.
This is tough because Obsidian users love bidirectional linking. That's the whole appeal.
It creates those beautiful, sprawling, cosmic graph views of how our thoughts connect.
The graph view is beautiful for a human looking for inspiration.
Oh.
But mechanically, every bracketed link you put in a text file is a potential extra file fetch for the API.
Ah, I see. So if I casually link to every tangentially related idea, or I bracket a passing mention of productivity.
You might trigger a cascade where Claude decides to load 20 completely irrelevant files just because they were linked in the text it was analyzing.
Right. The AI interprets a link as a signal of high relevance.
Only link to files Claude would genuinely need to read to execute a task based on that specific node.
Link upward to related maps of content, or link downward to active projects, but leave the associative decorative links out.
Now, Rule 17 is a structural rule I found fascinating. Use bullet points over prose for list-like content.
It seems like a stylistic choice, but is there a mechanical reason why LLMs prefer bulleted lists?
It comes down to the model's attention mechanisms. Large language models parse structured data much faster and more reliably than dense paragraphs. If you have 3 distinct use cases for a tool, putting them in a dense paragraph forces the model's attention mechanism to weigh the relationships between all the filler words.
The ands and alsos and furthermores. It has to do grammatical gymnastics to isolate the actual concepts.
Yes. By putting those use cases into a bulleted list, you create clear, undeniable token boundaries.
It prevents the model from conflating ideas.
It requires fewer connecting filler words, which saves tokens, and it dramatically reduces the chance of hallucination.
Which leads right into Rule 18, a brutal editing exercise, removing content Claude will never use.
Raw URLs with no context, half-finished thoughts, lengthy block quotes copied directly from external articles.
If you paste a 2,000-word article into your note just for reference, Claude has to read that entire article every time it accesses the note.
That is a massive token drain.
Yes.
Summarize the article into one clean sentence detailing its conclusion.
If you really need the full text for your own human reference, put it in a separate reference file and do not link it to your primary working note. Okay, I have to push back on Rule 19 here. Hard.
I thought you might. Let's hear it.
I understand the efficiency argument. I see the math. But wait, I use Obsidian for my brain. It is my personal journal. It is my idea scratch pad. It is where I vent and explore.
Of course.
If I have to strip out all my personal musings, my emotional context, and my sprawling exploratory thoughts just to save fractions of a cent on API costs, doesn't it completely ruin the tool for me?
It stops being a second brain and starts being a sterile, joyless database.
Exactly.
That is an incredibly valid concern, and it is the exact reason why Rule 19 is so critical. You do not have to sacrifice your personal space.
Okay, what's the rule?
The rule is split notes by use. In a traditional Zettelkasten system,
Let's define Zettelkasten for the audience really quickly.
Zettelkasten is a German term meaning slipbox. It's a note-taking method where you create atomic notes, one single idea per note, and link them together to organically grow complex thoughts.
Got it.
In a traditional Zettelkasten, you split notes purely by concept.
Yeah.
If you have a thought about ChatGPT, it goes in the ChatGPT note.
But for AI efficiency.
You also need to split by who is intended to read it.
So I maintain 2 separate files for the same concept.
Think about it this way. Have a ChatGPT usecases.md file. That is the sterile, highly optimized, bulleted list that Claude reads. It is clean, compressed, and efficient.
And the other one?
Have a completely separate file called ChatGPT personaljourney.md, or put your thoughts in a daily journal note. That is where you put your sprawling thoughts, your frustrations, your half-baked ideas.
You read that one. Claude never sees it.
Exactly. This modular approach is a core philosophy we see championed on the AI Coach by Anil Nathu, making AI work for you, not the other way around.
You don't have to sacrifice your personal thinking space. You just have to partition it so the AI isn't forced to read your diary every time you ask it to help you do your taxes.
Exactly. It is about defining strict boundaries within your knowledge management system.
All right, let's transition into Section 3. We have cleaned up the vault, the folders are flattened, the files are neatly named, deeply summarized, and perfectly partitioned.
But how do you actually ask Claude to do the work without accidentally racking up a massive token bill through bad communication?
Let's talk about prompting and sessions. Rules 20 through 24. Because how you prompt the model is the steering wheel. If your vault is the optimized engine, the prompt is how you drive.
The foundational rule here, Rule 20, is to scope every single request explicitly. You must tell Claude exactly which files to read.
If I just type into the chat interface, look at my vault, and help me write an intro for my upcoming workshop, what mechanically happens?
Claude essentially panics. Unscoped requests force the AI to cast a massive exploratory net,
It will start scanning your entire directory tree.
opening your maps of content, checking all your recent project files, and trying to guess what context might possibly be relevant to the word workshop.
You will burn tens of thousands of tokens on exploratory reads before it even begins to generate a response.
Instead, you must put blinders on the horse. You say, read only _index.md and mocitools.mud, then write a workshop intro.
You give it the exact coordinates. And that ties into Rule 21, avoiding vague instructions in general.
Tell me about my consulting work is a terrible prompt. It produces a massive wandering response.
Which means you pay for all the tokens the AI generates in its reply. You should ask for exactly what you want. Summarize mockconsulting.md in exactly 5 bullet points.
Rule 22. Controlling output length is a trap so many people miss. Most people forget that you pay for the tokens Claude generates, not just the ones it reads.
If you only need a yes or no answer or single paragraph summary, you have to explicitly state that constraint in the prompt. Give me 1 paragraph maximum.
Otherwise, Claude is trained to default to its standard, comprehensive, highly conversational, multi-paragraph essay format.
Now, Rule 23 is a trap I fall into all the time when I'm iterating on an idea. I will ask Claude to read a specific file and summarize it. Claude reads it, and we discuss it. A few minutes later, I will copy and paste text from that exact same file into the chat box and say, now write an email based on this specific text.
That is a fundamental misunderstanding of how the chat session works. By pasting that text again, you are literally forcing the system to tokenize and process the exact same information a second time.
Charging me twice for the same data.
Once the context is loaded into the active session window, trust that the model holds it. Don't repeat context mid-conversation.
Here's where it gets really interesting and honestly a little terrifying for anyone looking at their API usage.
Rule 24.
The framework dictates that we must start a new session for unrelated topics after 10 to 15 turns. Why? Because the chat interface we are all used to is essentially an illusion.
It really is an illusion. To you, it looks like a continuous scrolling conversation, like a text thread with a friend.
But large language models are technically stateless. They do not possess inherent memory of the conversation from turn to turn.
So how does it remember what I said 5 minutes ago?
Every time you hit send, the system does not just send your new short prompt.
Behind the scenes, the interface takes your new prompt, attaches the entire history of that chat session.
Every single question you asked, every single answer Claude gave, and the contents of every file that was loaded.
Packages it all up into one massive text bundle, and sends the entire thing back to the server to be processed again from scratch.
Wait. So if I am on turn 20 of a conversation, I am paying to resend, retokenize, and reread the first 19 turns every single time I hit enter.
It's like a snowball rolling down a hill, gathering tokens.
That is insane.
Yes. The token cost grows exponentially with every single message in a thread. If you spend 20 minutes talking to Claude about a workshop, building up thousands of tokens of context,
And then you casually pivot and say, okay, that's done. Now let's write an Instagram post for my dog.
you are paying to send all the complex workshop context along with the Instagram prompt.
That is quietly draining wallets all over the world. People are just sitting in one endless chat thread for weeks, treating it like a permanent assistant. Start fresh sessions, people. Cut the baggage.
Seriously, fresh sessions save dollars.
Let's move to section 4, our final major section, the master keys. We are looking at indexing, hygiene, and the absolute biggest conceptual shift for any Obsidian user.
Rules 25 through 33. These are the administrative files, the control panel of your vault.
The most important piece of this control panel, Rule 25, is your index file. You must keep your _index.md exceptionally lean.
Remember, because of the leading underscore we discussed earlier, this is the priority file loaded at the start of almost every single session.
So if it gets loaded every session, every single word in there is a recurring subscription fee. You have to write it like a tight military briefing, not a company handbook.
I shouldn't write, "Welcome to my vault." The AI tools section contains all my notes relating to artificial intelligence.
I should just write AI tools MOC, see mocitools.-md.
Exactly. The index is just a map telling Claude where the real information lives. And part of that mapping is enforcing boundaries, Rule 26.
You must exclude folders explicitly. In your index or your custom instruction file, you need a hard-coded system instruction that says, never load files from /500 archive / or /600 attachments / unless explicitly asked by the user.
Without this wall in place, a vague prompt might cause Claude to go rummaging through your digital garbage bin.
And speaking of instructions, Rule 27 suggests keeping behavioral instructions, how you want Claude to sound, its tone, its formatting preferences, in a totally separate file, like _claudeinstructions.md.
Right. You don't need Claude to adopt its professional corporate email writing persona when you're just asking it to quickly summarize a spreadsheet of data.
If you embed 500 words of persona and formatting instructions in your main index file, you load them every session, wasting tokens.
Isolate them and only call the instruction file when you actually need it to generate a specific stylized output.
Now we need to talk about a massive hidden danger that catches so many visual thinkers off guard, which is Rule 28, images.
The rule is to use images sparingly, because they are incredibly expensive. We are talking 1,000 to 2,000 tokens per single image.
It is staggering when you look at the math. One single simple screenshot of a web page costs more tokens to process than a dense, well-written 5-page document.
And if you just leave images sitting in your active project folders, Claude will process them visually every time it scans the folder for context.
It's the difference between shipping a grand piano across the country versus sending a postcard. They both convey a message, but one requires vastly more resources.
That is why Rule 29 dictates isolating all attachments. You create a single 600 attachments folder.
You dump every image, every PDF, every random media file in there, and you explicitly lock Claude out of it.
But what if you absolutely need visual context? That is where Rule 30 comes in, the text description hack. Use short text descriptions instead of images wherever possible.
I implemented this, and it is such a great hack. Instead of embedding a high-resolution image of a client's logo in the project file,
You just write logo context. Bold red sans serif word mark on a white background, minimal flame icon above the text.
that description takes maybe 15 tokens. The image takes 1,500.
And for an AI doing logic, marketing strategy, or summarization tasks, the text description is perfectly sufficient to give it the context it needs.
Moving from images to metadata, we have to address tags, Rules 31 and 32. The rule is to cap your tags at 3 to 5 broad tags per note and use consistent formatting.
This means no more tagging a file with A-tools, AI, artificial intelligence, ChatGPT, and tech all at the same time.
It is entirely redundant and expensive. Every tag is a token. If you use 12 overlapping tags, you waste tokens on metadata the AI rarely uses to complete a logical task.
And if you are inconsistent using AI tools with a hyphen in one place and A-tools with an underscore in another, you fragment the knowledge for the machine.
Pick a format, like kebab case with hyphens, and apply one broad categorical tag.
And to wrap up the hygiene rules before we hit the grand finale, Rule 33, audit your vault quarterly.
The final overarching lesson from the AI Coach by Anil Nathu is about maintenance. Token costs compound silently, so a quarterly audit is vital.
You have to go in every 3 months, merge tiny stub notes into bigger files, update your master index, move dead projects to the archive folder, and check for bloated front matter.
Think of it as pruning the digital garden so it doesn't overgrow the house.
Exactly. Pruning is essential.
Okay, we have covered all the rules, we've rebuilt the architecture, rewritten the notes, and mastered the prompts.
We have?
But there's one concept we keep hinting at. The aha moment of this entire framework. The map of content system.
The MOC.
What is the fundamental problem it solves, and why is it the absolute biggest win for an Obsidian user?
To understand the brilliance of this solution, we have to understand the depth of the problem. The biggest token drain in any interconnected knowledge base is what we call the Zettelkasten problem.
We touched on Zettelkasten earlier, right? The idea of creating atomic notes, breaking knowledge down into the smallest possible pieces.
Yes, so I might have 30 separate tiny notes about different aspects of artificial intelligence, all floating in my vault, linked together with brackets.
Which is phenomenal for human browsing. You follow the breadcrumbs of your own thoughts, jumping from note to note.
But it is an absolute nightmare for a large language model. To get a complete synthesized picture of your thoughts on AI, Claude has to load file 1.
It reads it, tokenizes the front matter, finds the link.
It then has to send an API request for file 2, load it, read its front matter, find the link. It has to do this 30 separate times.
The overhead of file paths, repetitive metadata, and overlapping context across those 30 fragmented files is astronomical.
So the MOC, the map of content, solves this fragmentation.
How?
What's fascinating here is how a strategy originally meant for human cognitive organization perfectly aligns with LLM context window optimization.
An MOC is a single, densely packed briefing file that synthesizes everything Claude needs to know about a broad topic.
Instead of letting Claude hunt down 30 atomic notes, you create MOCs.md. You write it like an executive summary.
It has the bulleted lists, the compressed prose, the dense top-down summary we talked about.
So when I sit down to do a task, instead of saying, Claude, look at my vault and find my AI nodes, I say, Claude, read MOCitools.md.
It loads one single file. It gets the entire synthesized context in one fell swoop. The token savings have to be ridiculous, right?
The math is incredible. The guide estimates that loading 47 fragmented atomic files to gather context might cost around 94,000 tokens due to all the overhead.
Loading one well-written, dense MOC file on the exact same topic might cost 2,000 tokens.
You are looking at an 80 to 95% reduction in token context loading just by centralizing the summary.
And the beauty is your atomic notes stay intact. You don't have to delete your web of thoughts.
You just build a clean, highly efficient executive summary on top of them, specifically designed for the AI to read.
It gives you lightning-fast responses, it dramatically lowers your API costs, and most importantly, it leaves a massive amount of the context window wide open for the AI to do real, complex reasoning, decision-making, and generation.
It fundamentally changes how you interact with your own data. It turns the AI from a confused librarian into a laser-focused analyst.
So what does this all mean? If someone is listening to this right now, staring at their messy, sprawling vault, realizing they are hemorrhaging API credits and feeling completely overwhelmed, where do they start?
Give us the top 3 immediate action items they can execute in the next 10 minutes.
Do not try to rewrite your whole vault today. That will lead to paralysis. Start with these 3 specific steps.
First, create a 000 mock folder at the top of your vault and write just one map of content file for your most frequently used topic. Just 200 to 400 words summarizing your key thoughts.
Second, audit just 10 of your most active daily use notes. Open them up and delete every single front matter field that Claude cannot immediately use to solve the problem. Strip it down to the absolute studs.
And the third?
Add one line to your main index or system instruction file, explicitly excluding your archive and attachments folders. Just wall off the junk.
Those 3 simple 5-minute changes will cut your token overhead significantly before you even rename a single file.
It is amazing how much leverage you gain from such a small structural shifts. We spend so much time obsessing over how to write the perfect prompt.
We buy prompt engineering courses, we download massive libraries of prompt templates.
But we completely ignore the environment we are dropping the AI into.
We do. We spend so much time optimizing our words, but how much time do we spend optimizing the workspace the AI lives in?
If artificial intelligence is going to act as our digital coworker, shouldn't we make sure its workspace is actually built for it, rather than just forcing it to sit at our messy human desk and trying to read our scattered handwriting?
Build the workspace for the worker. That is the perfect thought to leave on.
Thank you for joining us today. Visit the AI Coach website for more AI insights by Anil Napu.